In this class, we will talk about intersecting lines and discuss the different types of angles that are formed when two lines intersect each other. And then we will also talk about some of the properties of those angles. We will then prove that property, and finally we will work out an example of intersecting lines to find some angles using the properties that we will see in this class. And also we will use some of the ideas that we have seen in previous classes related to linear pairs of angles. Okay, so what we notice is when two lines are intersecting each other, suppose we say the two lines are line AB and line CD, they are intersecting at a point O, then the intersection of those lines creates four different angles. Okay, so there is an angle AOC and an angle BOD, and then we have a third angle which is AOD, and the fourth angle is COB. So basically there are four angles, or we say there are two pairs of angles. Now the pairs of angles are the angles which fall on opposite side of each other. They are called as vertically opposite angles. So angle AOC and BOD are vertically opposite angles. Similarly, AOD, which is marked by this red angle here, and COB, that is also one pair of vertically opposite angles. Now, what the theorem says is that if two lines intersect one another, then the vertically opposite angles are equal. That means angle AOC is equal to angle BOD, and angle AOD is equal to angle COB. So that is vertically opposite angles are equal. So what we have seen so far is that when two lines intersect, there are four angles that are formed, or in other words, two pairs of angles. And we have a theorem which says that the vertically opposite angles are equal. So let's prove this theorem that the vertically opposite angles are equal. And to prove this, we will use the ideas that we have learned in earlier class related to the linear pairs of angles. So let's do that. Okay, so we are trying to prove that angle AOC and angle BOD, which are vertically opposite to each other, they are equal. So let us first prove angle AOC is equal to BOD, and then we can prove the other angle as well. So if we have angle AOC, what we notice is the line OA, okay, is like a ray standing on the line CD. So if we just cover up the bottom half of this line OB, and if we just consider the figure where you have the line CD, and on that line CD there is a ray OA standing on top of it. That means when this ray is standing on top of the line CD, we have two adjacent angles, which is AOC and AOD. And because this is a ray standing on a line which is a straight line, therefore these are a linear pair of angles. And from our earlier class we know that on a straight line, the sum of the two angles, adjacent angles, the sum of the two adjacent angles is 180 degrees. So that means we can write now that angle AOC plus angle AOD equals 180 degrees. Now similarly, we can now think of this figure as if there is a line AB on which the ray OD is standing. So in which case the angle BOD and the angle AOD are linear pair of angle. That means their sum should be 180 degrees because it is the sum of the angle on a line, right? So these are adjacent angles formed by a ray standing on a straight line. So angle AOD plus angle BOD will be 180 degrees when we consider that the ray OD is standing on the line AB. So let's write that down. So we can write that angle AOD plus angle BOD is equal to 180 degrees. So we now have these two equations, which we will call as equation number 1 and equation number 2, and both these equations have the same value on the right hand side, that is 180 degrees. That means their left hand sides must also be equal. So we can equate the left hand sides because the right hand sides have the same value. So we can say that therefore angle AOC plus angle AOD, which is the left hand side of the first equation, that must be equal to the left hand side of the second equation, that is angle AOD plus angle BOD. So we have equated the two left hand sides of the two equations because the right hand sides of both the equations are the same. So now what we can do is we can cancel out the common terms on either side of the equation. So we have AOD on both the sides, angle AOD. So we will cancel out this angle AOD on both the sides. So we are left with this expression which says angle AOC equals angle BOD, which is what we set out to prove in the first place. So that means this angle AOC here is equal to angle BOD. These are vertically opposite angles and we have shown that they are equal. Next we will prove that the vertically opposite the other pair of vertically opposite angles are also equal, that is angle AOD and angle COB are also equal. In a similar way we can prove that AOD and COB are also equal. So let's make that proof as well. So we want to prove that angle AOD is equal to COB. Again, for this let us consider that we have a line AB on which a ray OD is standing. So in which case we have angle AOD plus BOD equals 180 degrees. So this angle plus this angle will be 180 degrees, considering that there is a ray OD standing on the line AB. So these two are adjacent angles which form a linear pair of angles. So considering that OD is a ray standing on the line AB, we can write angle AOD plus angle BOD equals 180 degrees. In a similar fashion, we can now think of the ray OB standing on the line CD. Okay, so we can consider this line CD and we have this ray OB standing on this line CD. Then we have that angle BOD and angle BOC are adjacent angles whose sum will be 180 degrees because OB is a ray standing on the line CD. So therefore we can write using the linear pair axiom that we have seen earlier in previous classes. We can write that angle BOD plus angle BOC equals 180 degrees. Okay, so now we can combine these two expressions. So if I can call this again as expression or equation number 1 and equation number 2, we have two equations where the right hand sides are equal. So that means we can also equate the left hand sides of these expressions. So combining equations 1 and 2, we can write angle AOD plus angle BOD equals angle BOD plus angle BOC. So now if we look at the common terms on both sides of the equation, we can cancel out that common term, which is the BOD term. so we can cancel that out. So we can cancel the BOD term, and what we are left is angle AOD is equal to angle BOC. So that is what we have proved. So hence this is proved. So we say that the theorem is proved. So when we have two intersecting lines, the vertically opposite angles are equal, and we will use this fact when solving many different problems concerning with lines and intersecting lines. Okay, so now let us work out an example using these properties, and that will give us better understanding of what you have seen. Okay, so to summarize, first of all, before we work out the example, when two lines are intersecting each other, there are four angles which are formed, and the angles which are on opposite side of each other are called as the vertically opposite angles, and the vertically opposite angles are equal. So let us solve an example now. So we have this set of intersecting lines. So we have a line AB which is intersecting with another line CD, and there's also a ray standing on this on both these lines, in fact, and we are given some information regarding the various angles that are formed, and we need to find some angles which are given here. Okay, so the information that is given to us is that angle AOC, which is this angle, okay, which is this angle AOC, plus angle BOE is this angle, so I'm going to mark that with red. The sum of these two angles is given to us to be 70 degrees. So we don't know what is AOC, we don't know what is BOE, but we know that the sum of those two angles is equal to 70 degrees. The next piece of information given to us is that angle BOD is 40 degrees. So I'll mark that with a different color. So we have this angle here, which is given to us to be 40 degrees. So based on this given information, we are asked to find what is the angle BOE. So that means we should find what is BOE. So that is the question mark for us. We need to find this angle here. So that's our question mark. And we also need to find the reflex angle COE. Reflex angle COE is not the angle on the inside of COE, but on the outside of COE. That is why it's called reflex angle. So we need to find, let me use another different color here. So we are asked to find this angle COE from here to here. Okay, so these are the two angles that we are supposed to calculate. Now, to find this, the first step that we will do is we will consider, we will look at these two lines A, B, and CD intersecting each other, and for a moment imagine that this line OE does not exist. So when we have just A, B, and CD intersecting each other, the angle BOD, which is given as 40 degrees, and the angle AOC are vertically opposite angles. So for the two lines AB and CD intersecting each other, AOC and BOD are vertically opposite angles, so they must be same. So that means AOC must be 40 degrees. So since, let me write down the step. Let me use standard colors. So we write, since angle AOC and angle BOD are vertically opposite angles, we know that AOC must be equal to BOD. So angle AOC equals angle BOD. So that is angle AOC equals 40 degrees. So we have now the value for AOC. The next piece of information given to us is AOC plus BOE is 70 degrees. So from this we can find what is BOE. So given angle AOC plus angle BOE equals 70 degrees, we can substitute for AOC to be 40. So 40 degrees plus angle BOE equals 70 degrees. So that means angle BOE must be equal to 70 degrees minus 40 degrees, which is equal to 30 degrees. So we'll have angle BOE to be equal to now 30 degrees. Now we want to find the reflex angle COE. For that we'll find first the internal angle COE, the normal angle COE inside this, and then we can subtract that from 360 to get the reflex angle COE. So let's first find angle COE. How to find angle COE? So to find angle COE, we notice that angle COE plus angle AOC plus angle BOE must totally be equal to 180 degrees, because that is the total angle on this line AB, which is AOC plus COE plus BOE. That should be 180 degrees. We know what is AOC, we know what is BOE. From that we can calculate what is COE. So from the figure we can see that angle AOC plus angle COE plus angle BOE should be 180 degrees, because they are the angles formed on the line AB, which are divided by the rays OC and OE. Okay, so we know what is AOC, which is 40 degrees. COE we don't know, plus COE plus BOE we know that to be 30 degrees, and that sum is 180 degrees. So 40 plus 30 is 110. So angle COE plus 40 plus 30, 70 degrees. 70 degrees equals 180 degrees. From this we can calculate angle COE equals 180 minus 70, that will be 110 degrees. So we have found the angle COE, which is 70 degrees. Now you should remember this is the inside angle COE, not the reflex angle. So let me mark that. So what we have found is this angle COE, which is 70 degrees. So to find the reflex angle, which is shown in the green arrow, which is the outside angle on COE, so we have to subtract the angle COE from 360 degrees. So we'll write reflex angle COE is 360 degrees minus the angle COE. So you have to be very clear about the distinction between the reflex angle of COE and the angle COE. So reflex angle COE is 360 degrees minus 110 degrees. So that will be 250 degrees. So we can now say that reflex angle COE I don't need to write angle, so reflex angle COE equals 250 degrees. Okay, so we have now calculated all the values that we were asked to find. We wanted to find angle BOE. We have found BOE, and that is 30 degrees, and the reflex angle COE is 360 minus the angle COE, which is 250 degrees. And if you recall from the definition of a reflex angle has a value between 180 degrees and 360 degrees. Okay, so if you notice in this example, we have used the ideas of linear pairs of angles, which we developed in the previous class, and also the ideas that we learned in this class regarding angles formed when two lines intersect each other.